Grind 75, C++, let's do valid parentheses. A nice easier one. So given a string S containing just the characters, basically parentheses, braces, and brackets, determine if the input string is valid. An input string is valid if open brackets must be closed by the same type, open brackets must be closed in the correct order, and every closed bracket has a corresponding opening bracket of the same type. Yeah, so this problem is pretty much just a check on if you know what a stack is and how to use it. So a stack being a last in, first out data structure. In C++, that's pretty much done with vectors. Yeah, it's usually built into the standard library of any kind of language. You don't even need to import anything. So let's get to it. So we're going to use a vector of characters, which is similar to a string. Actually, I don't know if a string has push back and pop back options, but you're also going to be just fine with vectors too. Vector of characters, and I call it stack. So for each character N in S, character C in S. This isn't the standard C++ type of loop. I think it's called a range-based for loop. I like it a little better when it works. It's a little more niche. Yeah, so we're going to have 3 conditions. If it's an opening bracket, so if it's a parenthesis, or if it's a brace, not abrasive, a brace, or if it is a square bracket, then we're going to put it on our stack. So stack.push back character. Otherwise, if it's a closing bracket, okay, so if it's a closing bracket and the stack is empty, that means there's no corresponding opening bracket, so that's an issue. So basically in this, we're going to be checking for failure conditions in this part of the loop. All right, so if it's empty, or if it's a closing bracket of some kind, so for example, if it's a parenthesis, and the back of the stack is not what we need as an opening parenthesis, so stack back. Oops. That came a little too early, so the back of the stack is not the one we need, so an opening one. Or, so it's going to be pretty much this same thing 3 times. I'm not really a fan of all this logical conditional checking. I don't think there's really a better way to do it because it's a little bit of a specific characters with specific meanings, and you do want to account for the different combinations and such. Yeah, so conditional. So okay, let's talk a little bit about conditional branching and compiler optimizations. Modern processors do it all the time, constantly, where they'll make several probabilistic predictions of what instructions are going to happen in the future. So it can put them in the pipeline. It can start having different bits of hardware, handle them, and then when you actually get to make a decision time on yes, we're going to need that logic or not, it'll throw parts of it away. They do that all the time. It is a net speed up on calculation speeds. That's just how it works. That's how modern technology needs to go. But when you have a lot of conditional logic like this, it makes it harder for the processor to predict what's going to happen next. So you end up throwing more of it away, especially when you're looking into parallelizing things and just really trying to get a super efficient code. If conditions are just killer for that. They don't make any difference on the theoretical algorithmic runtimes. But that's just something to keep in mind. It does have a pretty strong constant factor that it throws in there. Anyway, so this is a failure condition. So if it fails, then we're going to return false. And otherwise, so we push things onto the stack. So no, this is otherwise. So if the closing bracket matches with the thing at the end of the stack, which is the appropriate opening bracket. So we're going to just remove from the stack. Stack.pop back. And then lastly, we're going to make sure the stack is empty. So return. So for example, you might hit this ending return statement if they're all opening brackets, but then the stack won't be empty when you get to the end. So then that would be an issue, and you don't want that. So let's talk about space and time complexity. It's going to be linear time and space. So O of n, time and space. You pretty much have to look at every single character on the input. There's no way around that. You just have to. And then it's O of n space because of this stack variable to keep track of like what is been seen or not. There's not really a way to do it in less than that. So for example, this one, every single input, suppose it was just the opening ones and then the closing ones right after. That would still be n over 2 things in the stack at a time, even though it's going to return true. And then you could also come up with a failure case where maybe it's all just opening parentheses and then there's no closing ones. Then you're going to have the whole input string on the stack. That would be the worst case, but even if it fails, you could have up to half the things, or even if it returns true, you could have up to half the input on the stack at a time, which is still linear. That's pretty much how it goes. So let's step through a couple of examples. I'll do this one and then this one. All right, so empty stack to start. For character in S, first thing is an opening parenthesis. So this condition is going to hit true, and we're going to do this and skip the rest of the loop. Our stack is now this. Last character, the closing bracket. None of these conditions are true, so we're going to look at these. Neither of these are true. So that's not true, so we don't check that. This is true, so now we check this. This is not true. Meaning, so since these are separated by ors, we don't check this, we jump straight to return false. So that's a failure case. And then let's do, I guess, the correct one. So opening parenthesis, yeah, I'm gonna leave that there because this is gonna hit, and so we push that on the stack, so opening parenthesis. Now for a closing one, none of these are true. That's not true. This is true, so we check that. That is not true because it's a not. So then we're gonna go to, and then this isn't true. That's not true. So then we go to this, pop back. So our stack is now empty. But our next thing is an opening bracket. That's true. So then we push it onto the stack. Next character, closing bracket. None of these are true. That's not true because we have one thing. That's not true, so we don't check that. This is true, so we do check this. This is not true. And then that's not true, so we don't check that. So now pop back. Remove it from the stack. All right, opening brace. Meaning we hit this condition, and so we push it onto our stack. And then we skip those. So now closing brace, none of these are true. That's not true because we have one thing. This is not true, so we don't check that. This is not true, so we don't check that. This is true, so we do check this, but this is not true. So we don't hit this condition. So now we pop back off our stack. What do? We break out of the loop because that's the end, and the stack is now empty. So for example, there's no like opening thing still on the stack, meaning that there was a dangling one with no closing one, and then that's it. That's true. So then we return true, and that's correct. yeah, so we covered space and time complexity. We did examples. I'm going to skip that one because it's a little trivial. Let's give it a runtime or a run for syntax errors. Cool. Submit. And we're done. As soon as we mark it off. Thanks.